Okay, welcome back. Next, we're going to be talking about data manipulation instructions. And so let's look at how this would work. So first, let's give an overview of data manipulation. Data manipulation instructions allow numerical data stored in the controller's memory to be operated on with a control program. It includes operations involving moving or transferring numeric information stored in one memory word location to another word in a different location and carrying out simple operations such as converting from one data format to another. When thinking in terms of a word or a file, the two classes of data manipulation instructions are those that operate on a word data and those that operate on file data, which involves multiple words. So those are the two ways that we can be looking at it. The data manipulation instructions are output instructions which allow the movement, manipulation, or storage of data. So we can see that these various things how it's laid out in the way that the GUI is used is generated for the tools that are considered in the textbook. So next, let's talk about data transfer operations. Data transfer instructions involve the transfer of the content from one word or register to another. So here it would be the original data where it would be laid out, and after the data transfer has occurred, it moves to another location, now holds a duplicate of the information that was in the place where it was originally. So these are some of the possibilities of what you can be doing for data transfer. For the move instruction, it is used to copy the value in one register or word to another. When the wrong is true, this instruction copies data from a source register to a destination register. Here it gives you an idea how the logic 500 move instruction program would work. And so you can see that. Then we have the mass move MVM instruction function like a standard move instruction, except that a mass move allows data to be filtered out so that is not required to be moved. The mass parameters specified in the construction block is what perform this filtering process. The mass parameter can be either a word, address, location, or a numerical constant. Here is the MVM instruction program, what it would look like and how it would be manipulating the data. So you can look over that in more detail if you'd like to get some perspective on that. For move instruction, it's used to change the present time of a timer program. That's something that you can be using the move instruction for, so keep that in mind. The move instruction can be used to change the present count of a counter computer. So that could be a useful thing depending on what you want to be doing with your program. A file is a group of related consecutive words in the data table that have a defined start and end and are used to store information. So you can have ways of moving data using file instructions. And so you can have file to file, word to file, and file to word. Those are all possible. Here is just a little bit more insight into the logic 500 word and file addressing. And so if for a specific address, it represents the starting address of a group of consecutive words in the integer file 7. The length is 8 words, which is determined by the instruction where the file address is used. So those are all things that you can be pulling out. The FAL instruction, or file arithmetic and logic instruction, is used to copy data from one file to another and to do math and file logic. The control word uses 4 control bits: enable bit, done bit, error bit, and unload bit. Length represents the file length in words, position points to the word being operated on, and mode, all numeric or incremental, represents the number of file elements operated on a per program scan. So continuing, the destination is the address in which the processor stores the results of the operation, and the expression contains addresses, program constants, and operators that specify the source of data and the operation to be performed. The expression entered determines the function of the FAL instruction. So here is just showing you how you can do a file-to-file copy function using the FAL instruction. Here is a file to word using the FAL instruction, so you can look over that and pause the video if you want. And then you have the word to file copy instruction using the FAL instruction. Here we have the copying and copying and storing values for timer present presets. So this is something that you can be doing. Then we have the file copy instruction and the fill file, the FLL instruction, are high-speed instructions that operate more quickly than the same operations with the FAL instructions. There is no control elements to monitor, and data conversions does not take place, so the source and destination should be the same file type. So that's something that you want to be guarding for. Using the FL instruction to change all the data in a file to 0. So that's a possible thing that might be a benefit. And then you have the PLC drink manufacturing program. This would be an example of how you could be doing this type of capability. Next, let's get into data compare instructions. And so, data compare instructions are input instructions used to compare numerical values. The instructions compare the data stored in 2 or more words or registers and makes decisions based on the program instructions. So comparison instructions are used to test pairs of values to determine if a rung is true. And so these are all the possibilities. And so lim, MEQ, you can see all of that, EQ, equal, NEQ, LES. And so these are all just walking through the things that are on the menu. GRT, greater than, LEQ, less than or equal, or GEQ, greater than or equal to. So these are probably familiar to you. We saw this summary here on this first slide, and we're just walking through those details as we go along. So those are all possible things. The NEQ instruction is logically true when source A is not equal to source B. Otherwise, it is logically false. So thus we get some decisions that we can be doing. The less than LES instruction is logically true when source A is less than source B, otherwise it is logically false. The GRT instruction is logically true when source A is greater than source A, otherwise it is logically false. The GEQ, greater than or equal instruction is logically true when source A is greater than or equal to source B, otherwise it is logically false. The LEQ, less than or equal instruction is logically true when source A is less than or equal to source B, otherwise it is logically false. So those are how that would look for those localized implementations. So LES, EQU, and GRT compare instructions. This is where we can start to be looking at aggregating these things and get multiple types of assessments for each of those. The LIM, a limit test instruction, is used to test whether values are within or outside a specific range. So a higher and lower limit, that would be a useful feature. The low limit is less than the high limit. The instruction is true for test value 25 through 50. Instruction is false for test values less than 25 or greater than 50. This is just giving you a little bit more insight into using that type of a command. The low limit is greater than the high limit. The instruction is true for the test value of 50 and less than or greater than 50. And for a test value of 100 or greater than 100, the instruction is false for test values greater than 50 and less than 100. So you can see how that is working here. The Logic 5000 program with a limit compare lim instruction. So this is what the programming GUI would look like, and this is what it would look like in the ladder logic when you have that implemented. The MEQ, the mask compare for equal instruction, compares a value for a source address with data at a compare address and allows portions of the data to be masked. The MEQ instruction can be used to compare the correct position of up to 16 limit switches when the source contains the limit switch address and the compare stores their desired states. The MEQ instruction run when the data at the source address matches the data at the compare address bit by bit, that is less masked bits, the instruction is true. So that's a quick synopsis of some of the various instructions.